Hello. Can you hear me? Is my voice is audible?
Yeah, we can hear you.
Hello, yeah.
Okay. So then in the first class, actually I just given some overall idea. But this is our actual course. But before going to this course, we'll see some basics. Okay. So just I'll not take much time. I'll just take one day like that, 1 or 2 days. Is it okay? Or you want me to directly start SQL Server? Okay. Okay. Yeah. Then see, like we'll start with what is database. Okay. Then we'll start with what is database. So a database is a organized collection of interrelated data. Okay. So database is a organized collection of interrelated data. So this is what the definition of database. If you see this definition, here there are two terms. One is organized, another one interrelated. Okay, then. So what is interrelated means? So if you take like, for example, you take bank database. Okay, you take bank database. A bank database stores data related to customers. Okay, so data related to customers, data related to accounts, data related to transactions, data related to loans taken by the customers and bank employees. So what is this is? This is what interrelated. Okay, then customers related to accounts, accounts related to transactions, loans, employees. All this data is what interrelated. For example, if you take, for example, every university maintains what database. Okay, then. So if you take university database, so that stores data related to students, the data related to courses offered by university, data related to faculty. So what if this is, all this data is called interrelated. So that means a database stores interrelated data. A bank database doesn't store data related to university students. A university database doesn't store data related to bank customers. Okay, then. And one more point. So that is organized. Okay, then. So it's interrelated plus organized. So what is this is organized? Okay. See, not only storing the data is important. In database, not only storing the data is important, the data must be organized in such a way that accessing must be easy to access. Okay, then like you arrange the data in such a way that accessing must be easier. So like if you take library, in library, they arrange books. Suppose assume all the books are kept in one rack. If all books are in one rack, the problem is finding the particular book is difficult, time taking. But if you keep separate racks, one rack for computers, one rack for electronics, one rack for mechanical, one rack for, okay. So if you keep separate tracks, finding the book is what easy. So similarly, in database also, not only storing the data is important, the data should be organized in such a way that accessing should be easy. But in database, what is the structure they use? The most of the databases uses a structure called table structure. So that means inside the database, how the data is organized. So this data is organized by using tables. So customer data stored in one table, customers table. Okay. So accounts data stored in one table, accounts table. Next, transactions data stored in one table, transactions table. So the data stored in different tables. So what are the advantages? You want customers data. Just go to the customer table, access the data. You want to loans data. Just go to the loans table, access the data. So accessing is easy. So in libraries, the books are kept in separate racks. In database, data stored in separate tables. That's the okay. Then, so for example, a university database stores data related to students, courses, faculty, and a bank database stores data related to customers, accounts, and transactions, etc. Okay, that. But earlier, companies maintained only one database. If we go to some years back, uh, companies maintain only one database. But nowadays, every company maintains two databases. Okay. So every organization maintains two databases. So what are the different types of databases? Okay. Types of databases. Mainly two. So one is OLTP, another one OLA. So nowadays, every company maintains two databases, OLTP, OLA. So what is OLTP stands for? Online transaction processing. What is OLAP stands for? Online analytical processing. So OLTP stands for online transaction processing. OLAP stands for online analytical processing. Okay, so you take Amazon. Amazon maintains two databases, OLTP and OLAP. So what for companies use OLTP? Companies use OLTP for storing day-to-day transactions. Okay, na? Companies use OLTP for storing the day-to-day transactions. So they use this OLTP database for storing day-to-day transactions. Okay, like if you take bank, okay, so every transaction is recorded in OLTP. So you go to the bank, you do money withdrawal, money deposits, money transfer. So all the details are stored in this database. You go to Amazon, you place order to buy product. The details are stored in OLTP. So this is for storing the day-to-day transactions. Okay. Sorry. And companies use OLAP for analysis. So if company wants to analyze the data, they use OLAP. If company wants to run the business, they use OLT. One is for running the business, another is for to analyze the business. Okay, that. So because some years back, their focus is only running the business. But nowadays, what focus is on running the business as well as analyzing the business because of big competition, huge competition. Okay, then. So now, so organizations uses OLTP database for storing day-to-day transactions and OLAP for analysis. Okay, then next, like you can say OLTP is for running business and OLAP is for to analyze business. Okay, then no. So if you take Amazon, Amazon wants to analyze the last 5 years, 10 years sales data. They want to analyze the sales revenue. So they use OLAP. Okay, then no. So, but here actually, see, what I'm saying is, listen, applications, what you take applications, okay? Applications generate the data. Suppose, for example, if you take banks, you use net banking application or you use mobile application to do money transfer, okay, balance inquiry, something. You use mobile application. So the applications generate the data. Applications generate the data. Whatever data generated by application, that data stored in OLTP database. Okay, so applications generate the data. The data generated by application is stored in OLTP database. But the data stored in OLTP is not suitable for analysis. So because if you want to analyze the data, you need history. But this database stores only current data. It will not store historical data. So how you suppose measure the performance of a student, like is strong in academics or not? How you measure the performance of a student? So if you know past, suppose records, like, okay, mark sheets. So if you know the mark sheets of the student, then you can analyze. So that means for analysis, what is required is history. But this database stores only current data, present data, but it will not store historical data. But to, okay, then, so this database stores current data plus historical data. That's why we can use this database for analysis. Like, see, suppose you take bank example. I go to the bank, I'll ask customer address. Then from this database, they can give only current address of the customer. They cannot give previous address. So I'll ask her in 2020, what is the address? 2015, what is the address of the customer? Means they cannot. But from this database, now you can get the current address, you can get the previous address. In 2020, so what is the address? In 2015, what is the address of the customer? So you can get it from this database because this database stores history. So then, so application generate the data. Data generated by application is stored in OLTP. But the data stored in OLTP is not suitable for analysis. That is why they copy this data to another one. So what is that is OLAP database. And next, once the data is copied to OLAP database, then analyze. That's this is the what like flow then. So application generate the data. So data generated by application is stored in OLTP, and data stored in OLTP is not suitable for analysis. Then again, they copy this data to OLAP, then analyze the data. Okay, then. So the copying the data from OLTP to OLAP, that process is called ETL process. Okay, so copying the data from OLTP to OLAP, that process is called ETL process. Extract, transform, load. Okay, then. So in each, in every phase, like in applications, how the applications are developed. How you develop these applications? By using what? Java, by using .NET, by using Python. Okay, so by using HTML, JavaScript, React. Okay, so then you develop the applications by using these technologies.
No, I did not.
Okay, so applications are developed by using these technologies. Next one, how this database is maintained? By using a technology, SQL Server. So what are the ETL tools? There are a number of ETL tools are like one is ADF, ADB. Next, another one, Snowflake, MSBI. What are these? These are all ETL tools. Okay, then. So Azure Data Factory, Azure Data Bricks, Snowflake, MSBI. So how to maintain this OLAP? Again, OLAP is maintained again by using SQL Server. How to analyze the data? By using some technologies like Power BI, Tableau, next one, Python. So we can use these technologies. That's all. Okay, then. So in the last class, I think one is asked what is ETL is. Okay, that's it. This is ETL. The main purpose of ETL is migrating the data from transactional database to analytical database, OLTP to OLAP. That's all. So that is the purpose of ETL. Okay, then.
Hi, Vijay. Sorry, I have a question.
This
Can
is,
I?
yeah.
Yeah. What is about that PL and what its work? PL.
PL.
Something called like procedural language something.
Yes. See, here in SQL Server, we have two languages. One is SQL, one is TSQL. If you go to Oracle, there are two languages, SQL and PLSQL.
Okay, got it.
Understood? Then here instead of TSQL, they use PLSQL. But concepts are same, coding is same, everything is same, but name is different. Okay, whatever the concepts are there in TSQL, the same concepts are there here, just name is the different. In SQL Server, we call it as TSQL. If you go to Oracle, they call it as PLSQL. Then. Okay, next. That's all. So this is about the two databases. Okay, then. That means if you learn this SQL Server, it is useful for both. Okay, you can be part of this development and also you can be part of this development if you know SQL Server. So both needs SQL Server. Okay, both needs SQL Server. You need so in OLTP development they need SQL Server. In OLAP development also they need SQL Server. Okay, then. So that is why the database is important for any application development. Okay, knowledge is important. Database knowledge is important. Then. So, and the day-to-day operations, the day-to-day operations on database includes CRUD. The day-to-day operations on database includes CRUD. C stands for create, R stands for read, U stands for update, D stands for delete. So create the data, read the data, update the data, delete the data. But the thing is, you don't directly work with database. You don't directly go to database, store the data. You don't directly go to database, update the data. Okay. You don't directly interact with databases. You take the help of a software to work with the database. See, working with the database means storing, reading, updating, deleting like this. So to work with the database, you take the help of a software that is called DBMS. Okay, then. So what is DBMS stands for? Database management system. Okay, then. So you can say like a DBMS is a type of a software. So it is a software used to, okay, create and to manage database. So you don't directly work with the database, you work with the database with the help of what? DBMS. Okay, users work with database with the help of DBMS software. So you can say, like you can say something like this. What? Suppose, for example, the user uses DBMS to work with database. We can say it is an interface, like it is an interface between user and database. So user uses DBMS to work with the database. Like if you want to update, you give request to DBMS, DBMS will go to the database, update the data. You want to delete, you give request to DBMS, DBMS will go to the database, delete. So any operation on database, you give request to DBMS. Then, okay. So then, but again, what are the different types of DBMS? Okay. So what is the evolution of DBMS? What the evolution means? Evolution means step-by-step development. What the evolution means? Step-by-step development. Means suppose in the beginning, so what systems are used? So actually, data storage is started from 1960s. Companies started storing the data from 1960s onwards. The first system, initial system was FMS. 1970s, the companies started using HDBMS, next NDBMS, 1980s RDBMS. Okay, 1990s RDBMS. That's it. So this is the evolution of DBMS, step-by-step development in DBMS. So initially, data storage started with FMS, later HDBMS, NDBMS, RDBMS, ORDBMS. So what is FMS stands for? File Management System. So what is HDBMS stands for? Hierarchy. DBMS. Okay, then next. NDBMS Network DBMS. RDBMS. Relational DBMS. What DBMS stands for? Object Relational DBMS. Okay, there. So this is what the different DBMS. Okay, there. So initially data stored in files. Later they shifted to databases. They started using the databases because they had some problems with files, storing the data in files. They had some problems. So then they started using databases to overcome the problems of file system. They started using databases. But the first DBMS was HDBMS. They had some problems. NDBM, they had some problems. RDBMS. So to overcome the problems of one system, they introduced another system. Okay, but these systems are outdated. FMS is outdated, HDBMS is outdated, NDBMS is outdated. So what you must know is, you must know RDBMS, Relational Database Management System. So you need these two. We don't need these three. because they're outdated, not now, they're outdated some years back. So no company is using this. Now, so what is RDBMS then? So RDBMS, okay, then RDBMS concepts introduced by a person called EF Card. Okay, so he introduced RDBMS concept. Okay, then next, and EF Card introduced some rules. How he introduced RDBMS? He introduced RDBMS with 12 rules. They're called card rules. They're called card rules. Then, okay, so a database, that supports what? That supports all 12 rules. All 12 rules called perfect RDBMS. Okay, a database that supports all 12 rules is called perfect RDBMS. Okay, now then. No, but this is not the right time to discuss about these 12 rules. Okay, so like once after completing the SQL concepts, then you'll understand these 12 rules. Okay, then, but remember that, so these two are important for you. Then, so here, what is this? This is introduced by EF Card. RDBMS concepts introduced by EF Card. He introduced 12 rules. So if any database that supports 12 rules is called perfect RDBMS. Then, so here, then one rule is there. What the rule is? Information rule. Okay, one rule is there, information rule. So according to information rule, the data must be organized in tables, that is rows and columns. So that means if at all you are using RDBMS, so inside the database, how you arrange the data? If you are using RDBMS systems, then inside the database, how you organize the data in the form of tables, rows and columns. Okay, then. So like, for example, let's take one example. Suppose then, for example, let's take customers data. Okay, na? Then, so suppose I want to store customers data. Then customers data. So how you store the customer data in database? By using this structure, that is table. Okay, table. Then by using this table. So inside the database, you store the data by using this table. One is what? Like say customer ID, customer name, like customer city, customer age, something. Okay, ID, name, age. Like suppose, for example, ID is 10, some name Sachin, some age 40, like, so ID is 11. Okay, some age like 30, something. You store the data like this. If at all you are using RDBMS, so inside the database you store the data like this. Okay, now then something. So okay, now so you store the data like this. Then, like here, you see this. Here, what are these verticals are called? What are these verticals? So these verticals are called columns. What are these verticals are called? These verticals are called columns. Columns are what fields, or you can say attributes. Okay, then. Okay, no? Then. So what is this horizontal is called? This horizontals are called this horizontal. What this horizontal is called? This is called row. This is called row, or you can say record, or you can say tuple. Okay, then. So the verticals are called columns, or fields, or attributes, and this horizontal is called row, record, tuple. Okay, so the table contains rows and columns. So in this table, how many rows are there? In this table, how many rows are there? Okay, then in this table, how many rows there? So this table contains 3 rows. This is row 1. This is row 1. Second row, third row. How many rows are there? 3 rows. The first one is not considered row because it contains field names. This is not row. This is the row. This is the row. This is the row. So how many rows are there in the table? 3 rows. Okay. How many columns are there in this table? 3 columns. This is one column. This is second column. This is third column. How many columns are there? 3 columns. How many rows are there? 3 rows. Sir, okay? Understood then. No. And so inside the database, you store the data like this in the form of tables. You want to store employees data. So create one employee table, store the data. You want to store students data, then create one table, store the data. Okay, then. So because table is a simple structure, a table is a simple structure. So when structure is simple, working is also simple. When table structure is inside the database, you store the data in the form of tables, but table is a simple structure. When structure is simple, then working with the database is also simple. Okay. But here in these systems, the structures are complex. When the structures are complex, working with the database is also complex, difficult. So that is the reason. So once RDBMS is introduced, RDBMS became famous. RDBMS became famous. The most of the companies started using RDBMS. Most of the companies migrated from most of the companies. Most of the companies migrated from file management system to RDBMS. If they're already using HDBMS, they migrated to RDBMS. If already they are using NDBMS, migrated to RDBMS. So most of the systems, companies, migrated from these systems to RDBMS. RDBMS became very famous. Okay, then next. So like this. Okay, then. So just I'm adding that to the notes. Then. Oh, next. Understood then. So if anything, any queries, you can ask this in chat box. There is a chat box. You can use the chat box to ask queries, anything. If you are not understood, if you want me to repeat Okay, then next. And another one, RDBMS. Every table must contain primary key to uniquely identify, okay, to uniquely identify rows, then to uniquely identify the records or to uniquely identify the rows. So every table must contain primary key. Okay, then. So suppose, yeah, for example, if you take customer table, okay, if you take, suppose here, for example, I'm storing the data like this. Inside the database, inside the table, I'm storing the like this, name, job, salary, like this. This is employee table. I'm storing the data like this, e-name, job, salary. But if you store like this, what the problem is, uniquely identifying employees is difficult. Uniquely identifying employees is difficult because there may be number of employees with same name. There may be number of employees with same job, same salary. Names can be same, jobs can be same, salary can be same. So uniquely identifying employees is difficult. So that is the reason every organization uses what? Employee ID. Okay, then. So like if you go to, for example, banks. So banks uses what? Account number to uniquely identify the accounts. So what are the examples for primary keys? Like what he's saying is, if table is there, compulsory primary key must be there. So if primary key is not there, so uniquely identifying is difficult. So compulsory the table must contain primary key. So what are the examples for primary keys? So banks uses account number. So companies uses employee ID to uniquely identify the employees. So Indian government uses Aadhaar number to uniquely identify the persons. Sorry. Income tax department uses PAN number. Here in India, then income tax department uses PAN number. So election department uses voter ID. Then what are these? All these are what examples for primary keys. Like in US SSN. Okay. Then so their purpose is what? Uniquely identifying. So this is another rule. If table is there, compulsory primary key must be there. Okay, then. Now. So like this is about what RDBMS. Like in RDBMS, you store the data in the form of tables. So the table contains rows and columns. Okay, then. So the table must contain primary key. Okay, then. So what are the other features of RDBMS? RDBMS features. RDBMS features. One is easy to access and manipulate data. So accessing and manipulation is easy. I'll explain this. Less redundancy. So redundancy means the duplication of data. So this is less. RDBMS provides more security. RDBMS guarantees data quality. RDBMS supports data sharing. RDBMS supports transactions. So these are the other features of what RDBMS. So easy to access and manipulate, less redundancy, more security, guarantees the data quality, or you can say data quality or data consistency. Okay, then. Or you can say data integrity. All the three terms same. Data quality, data consistency, data integrity. Okay, then supports sharing, supports. I'll explain this. Then I'll explain all this. Next, what are the RDBMS softwares? What are the RDBMS softwares? Means, like if you take, for example, OOPS is what? Like OOPS. Okay, na? OOPS is a programming style. OOPS is a programming style. OOPS is a concept. This concept is for programming style, programming methodology. So what is Java? Java is a language implemented the features of OOPS. Okay. What is Java? Java is a language implemented the features of OOPS. So similarly, RDBMS is a concept. RDBMS is a concept. So what are the softwares implemented the features of RDBMS? Like SQL Server. SQL Server is one. Oracle is one. MySQL is one. Next, PostgreSQL is one. RDS is one. Then all these, so all these are examples for RDBMS softwares. Okay, then. So now, like if I ask you what is SQL Server means, what is your answer? So your answer is what? SQL Server is a what? RDBMS software. What is Oracle is? Oracle is what? RDBMS software. All these are belongs to one family. What that family is? RDBMS family. Okay, then. Now, so then RDBMS comes with some features. Then, so SQL Server is the software implemented the features. If I ask you what are the features of SQL Server, you can give this list. SQL Server, easy to access and manipulate, less redundancy. What are the features of Oracle? You can give this list. Then, okay, now. So then, like, what is the meaning? User uses what? SQL Server to work with the database. User uses SQL Server to work with the database. All these softwares are used to work with the database. Okay, then because all these are what? All these are DBMS softwares. So why we use DBMS? We use DBMS to work with the database. You don't directly interact with database. You interact with database through DBMS. So these are the different types of DBMS. We use one of the type. What the most popular is? RDBMS is most popular. So we use RDBMS, SQL Server. Okay, na? Then. So suppose, for example, like here, see how you go to the office every day, how you go to the office. If I ask you, so we use vehicle. Which vehicle? Either, so here, suppose four-wheeler or, okay, then. So four-wheeler. Which four-wheeler? Some like car is there. Okay, na? Some car is there. Okay, then. So like some car. Next year, how companies maintains what? Database. They use DBMS. Which DBMS? RDBMS. Which RDBMS? SQL Server. That's all. How company maintains databases? By using DBMS. So which DBMS they use? RDBMS. Which RDBMS they use? SQL Server. That's all. Then. So if I ask you what is SQL Server means, your answer should be SQL Server is RDBMS software. What for SQL Server is used? SQL Server is used to maintain the database, to work with the database. If user wants to work with the database, he takes the help of SQL Server. He gives request to SQL Server. SQL Server go to the database, work with the database. That's all. Then
So the database is like a storage space.
storage.
Yeah.
Database is a storage. Okay, then. So what is this is? See, this is a software. So database is a storage. Like simply like so user uses what Windows or any OS to work with hard disk. Okay, you want to work with hard disk, then we take the help of Windows software to work with the hard disk to create the files in hard disk. Then we use Windows. Similarly, to work with the database, we use a software called SQL Server. Okay, then. So that we will be learning how to store the data in database, how to store the data. Okay, then. So that you'll be learning from these codes. Okay, then. Now. So here in the next class, we'll discuss these points. In the next class, we'll discuss. So easy to access. What are these points? What are the futures? We'll discuss this. And we'll also discuss RDBMS. It will not take much time. It just takes 5 minutes because it is not completely different. It is an extension to RDBMS. So we'll discuss RDBMS and these points in the next class. And once this is completed, we can start SQL Server. So before you go to the SQL Server, you need some basics. Then. Okay.
Yeah, that's fine. So how many days that we are going to schedule the sessions in a week? That we have to plan it, right? So if it is a 2 days in a week, means it won't be sufficient, right?
Yeah. We'll get back to you today. Okay. Today means tomorrow morning, US.
Sure, Vijay.
Okay.
Yeah, that's fine. Yeah, that's fine. Yeah.
I'll talk to Amit then.
Yeah, yeah. Sure.
And we'll fix and I'll get back to you.
Sure, Vijay. Yeah. Great. Thank you.
Okay. Okay. So we'll continue this tomorrow.
Tomorrow means next week. Yeah.
Tomorrow or okay. So
Yeah.
I'll talk to the Amit and I'll fix up and get back to you. Okay. Na? The group is there now, WhatsApp group.
Yeah. Right.
We'll discuss and we'll fix the timing days. Okay.
Okay.
And he will also contact you.
Sure, Vijay. Yeah. Got it. Thank you.
Okay. 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 Bye.
Thanks. Bye.
Yeah.